Welcome to the sixth of an 8-video series on rational expressions, subtraction. You'll notice here, if you watched the previous video about addition, that these are the same steps that we would use for a subtraction problem. So I'll keep those up there from the previous video, and let's go through those 5 steps for this particular problem. Step 1, we're going to factor our denominators. Done. Step 2, let's decide what's missing. Well, this fraction's denominator is missing an x plus 2, and this one is missing an x plus 4. And now that we've decided what's missing, that will guide us on step 3 as to which one to multiply by. I'm going to multiply by these ones, effectively inserting what's missing into the denominators to make them match. And this gives me a common denominator. Now let's continue in step 3, multiplying the fractions together. Really, in this portion, I've done nothing more than physically put the 2 fractions on either side into 1 by placing all the factors next to each other. Notice I have the matching denominator, which was the goal of step 3. And now I can continue multiplying, as you'll notice here and here. I could also multiply out the denominators in their entirety, but there doesn't seem to be any reason to do that because the goal is to keep the denominator the same and combine the numerators. So it's the numerators that needed to be expanded into standard form. But one thing that makes subtraction a little different is how do we subtract the numerators? In other words, what do we do with this minus sign here? Now I'm going to type something out now that I don't recommend doing, but just for thought's sake. To subtract something literally means to multiply it by -1 and add. Now I never write this out, but it gives us a good thought about the process. Now multiplying that fraction by -1 would entail either multiplying the numerator or the denominator by -1. It would be my choice, but I wouldn't choose to mess with the denominator, so that -1 essentially distributes to the numerator. Now I don't recommend ever writing any of that out. It's a lot of writing for no reason, and I have a nice shortcut for all of that. My shortcut is to do this. Notice, the subtraction essentially is like a -1 that multiplies the entire numerator. And what you'll see here is that in the bottom box, I've essentially changed all the signs from the top box. So think of the subtraction as multiplying the second numerator by -1, or changing all the signs in the second numerator, and you can avoid all that writing that you saw before. It's a nice shortcut. On to step 5. Step 5 is to simplify if possible. Well, looking at the bottom line, specifically the numerator of the bottom line, you'll notice that there are some like terms in there. The positive 2x and the negative 4x can combine. I've rearranged the terms just out of a sense of tradition, highest exponent to lowest, and that is the answer to this problem. Let's look at a different problem and go through the 5 steps again. In this case, step 1, factoring the denominators, is a little unusual because on the right the denominator doesn't factor, the x plus 2 does not factor, and on the left side, the 5, there's no denominator at all. I find it convenient to, when I'm missing a denominator, to put it as over 1, just to keep my wits about me. On to step 2, which is a mental step where you decide what's missing. What's missing over here is an x plus 2. What's missing on this side? Well, you could say there's a 1 missing, but really there isn't anything missing. because multiplying that by 1 on the bottom wouldn't change anything. So on to step 3 then. We're going to multiply by an appropriate 1 to get our denominators to match. Multiplying those together, we'll notice that our denominators do match. And further multiplying out the numerators, notice here, I've now completed step 3. Step 4, we keep the same denominator and subtract the numerators, but remember this subtraction is going to apply to this entire quantity and change all the signs. Notice the sign changes. Step 5, simplify if possible. Well, you can see in the bottom that our numerator does have like terms, as it quite often does. Combining like terms gets me to my final answer. Here's one last problem. Let's go through our 5 steps again. Factor the denominators. I've done that here. Now deciding what's missing is going to be a little different here than you would normally expect. In this fraction, there's clearly an x minus 3 missing. Now, you might also say there's an x missing, but we already have an x squared, which is basically 2 factors of x. So I'm not really missing anything on that side but an x minus 3. Now on the other side, we're clearly missing an x plus 2, but we're also missing a factor of x. And here's what I mean by we're missing an x. You might say, well, we already have an x. But we're missing a factor of x in the following sense. This side has an x squared in it. This side only has an x in it, so multiplying one more x in will make those match, and we'll get a common denominator. So I'm going to multiply in the appropriate 1s to get all my denominators to match. Here I've multiplied everything together, but really only in the sense of physically putting all the factors next to each other. Notice my denominators do match. They don't appear to be exactly the same, but mathematically notice they are the same. And multiplying everything out, I get this. You'll notice my 2 denominators on the bottom are both slightly different than they were above. It's just a more standard way of writing the factorization. Also notice I multiplied these, and I multiplied here as well. That's the end of step 3. So now I'm going to keep my denominator the same, but remember this subtraction is going to apply as a multiplier of -1 to the next numerator, giving me basically a sign change for every term in my second numerator. And finally, simplifying if I have like terms, well, in the bottom numerator, you'll notice there are 2 pairs of like terms. Combining both pairs ultimately gives me this. Now's a good time to pause the video if you want to confirm the algebra for yourself. And that gives me essentially what you could consider your final answer to the problem, and most would. By the way, I'm done with this problem, but afterthought for the people who are up for an algebra challenge here, while there's nothing wrong whatsoever with this answer, we could factor a negative out of the numerator and write it in front of the fraction instead. I am by no means suggesting that you have to do this, but mathematics is an art as well as a science, and artistically speaking, this looks a little neater to the average mathematician. I could even take that negative sign and distribute it into the denominator and change my x minus 3 into a 3 minus x. Now this is highly unusual, and I don't know very many mathematicians even who would bother to do that, but in the spirit of mathematics being an art, that looks even neater than the thing above it. But again, these bottom two answers are not the traditional way of writing it. Most professors, teachers, or websites would expect the negative x squared minus 2x minus 15, the first answer I came up with. And that completes the 6th of 8 videos.